Okay, so this is my code for the second question, part B, right? I created a function. I hope you all can see my screen.
Yes, ma'am.
Yes, okay. So I created a function named all underscore outcomes, all outcomes, right? And within brackets, I didn't give anything, right? But still, if you want to, you can give arguments if you want to. Doesn't matter. Just because everything is static, I didn't give anything. And I know this particular die has 6 values from 1 to 6. So I took this one, 1 to 6. This is a very, this is lengthy just because I have not used any inbuilt function or package for this. But this is the thing that I've done from scratch. Anybody should be able to understand this, right? So I took the values from 1 to 6. So before explaining these things, I'll jump into this one, right? Just because every die has the same set of values within the first for loop. So again, I have nested for loops here. Within the first for loop, I took a variable as A, B, and C, okay, in values. So what is values? It's a vector from 1 to 6, right? So when A is equal to 1, it enters this for loop, right? And I opened up a new vector called out, right? And in that particular vector, I wanted the first element to be A. A is outcome, right? Outcome number 1, 2. So I have not sampled it. I'm not randomly picking anything. I'm taking it in order. So the first value of the die is number 1. So in this vector, for the first memory location, I am allocating A when A is equal to 1. Okay, out 1 is 1. Keeping that as it is, I'm going to have the same vector's second place in the first value that I'm getting in the next die. So that is again 1. First outcome is 1, 1, 1. I'm getting ones in all the dice. And in the next for loop, to the third place of this particular vector, I am putting the first value that I am getting. So likewise, I have to repeat until I meet all the 216 observations. So that I used a while loop while I have to have a counter starting from 1 up to 216. Okay. So while this condition is true, these things are looping. Okay. Once you go here, I combine this out vector in a list. You know, in a list, we can have numbers, strings, even another vector in a list as elements. That is the property of list. Okay, so I created a new list. In this list, I am going to have all these 3 outcomes. So how do you call a particular value in a list? By double square brackets. From a square bracket, you call a particular index of a vector. By double square bracket, we learned this before. By double square bracket, we are going to access the memory location of a list. Okay, so when count is 1, that is the first element of this particular list, I am allocating my new vector called out. So this particular thing has out 1, out 2, out 3. Actually, when it comes to this position, the size of this out vector is 3, because here out 1 is the first element, out 2 is the second element, out 3 is the third element. So all these 3 elements are now in vector out, that vector is put to the first index of this list. Then I have to repeat the same thing 216 times. So I increase the count by 1. Now, when it goes here, count is equal to 2. 2 is less than or equal to this particular value, then it repeats. So likewise, when count is 217, it checks this condition. Condition is false. Usually, you know, while loop iterates until the condition is false. When condition is true, it iterates. When condition is true, it iterates. When it is false, it jumps out of the loop. Now this list is consisted with 216 different vectors, right? And I'm outputting the list. That is what I have done in the first. So even it is a matrix, you can do it. Just like the union image, you can do that. So if you are not happy with this one, what you can do is number of dice and let's say face, number of faces that you have. So you can put this value, this thing here, this thing here, right? Then you make it dynamic. And when you are giving the function, you can simply say this. Still you are getting the same thing. Okay, so I'll run that and show you. So as a list, I'm getting everything. This is just another way. This is not the only way to do this, right? As a list. So can you see this list? The size of this list is 216, right? And this is the list of vectors. Under each element in this list, I have a vector. Okay, so that is how I thought about this. You don't have to make this dynamic. You simply can remove these things. If you do that way, you have to remove this. You're getting the same thing, right? In a function, you always don't have to pass arguments. There are functions which don't have any arguments. Why do you make it a function? Just because you want to use them within another function in the future. That is the reason. Okay. And in the second part, what they ask is to compute a probability. So write a program to get all possible outcomes for this experiment, right? So when you're asked to write a program, you have to write it as a function, okay? So this is a question for functions. Then compute the probability that the sum of dice is greater than 11 and less than 17. So what does that mean? You have to take the summation of all these and check whether the condition satisfies. So how I did that was probability checksum. This is the function name that I gave. Okay. And I called this particular function here and assigned it to an object called all. All outcomes is my previous function. Okay. I assigned it to an object and I set the counter. Then here in the for loop, I'm going from 1 to 216. You can even put 216 here without doing this, doesn't matter. And for summation, from this function, right? So that is this one. That's a list because they returned a list. Okay. How do you access values, each and every value of a returned list? By double square bracket. So in this particular list, I'm going to go for the ith element. That is, in the first iteration, it's the first element. Second iteration, second element, likewise. This element, this element, this element. In that element, again, you can individually access each and every element of this. So in the ith element of the list, say 108, so they are referring to this one. When I is equal to 108, 108th element, so that is this one. Okay, we have to access each and every element of this within this. Okay, so first one is this one, second one is this one, third one is this one. This seems complex, but the logic is very simple. Within the list, I access the elements. Okay, I'll just show you. Let's say B is a list. Okay, say the first element is a number. Let's say the second element is a vector. Right? Let's say again the third element is a vector. Let's say something like this. So when you print B, see, this is the first element of the list. This is the second element of the list. This is the third element of the list. If you want to access the second element of the list, how do you do? B within double square bracket, you put the element that you want. So it is a vector. You are getting all three numbers. 1, 2, 3. Further, if you want to access these things individually, how do you do that? You put another square bracket and give the element, which element you want to access within this. So let's say you want to access the third element, you give 3 here. So it's this one. Let's say you want to access this particular number. So that is in this list 1, 2, 3. It's the third element of this list. And there also you can individually access these numbers. First number, second number, third number. So if you want to get 6, you have to write it like this. Extracting information out of a list. Okay. If you have questions, just interrupt me and ask. So that is what I have done here. That is how I have gotten the summation. By using this function, okay, that's how I have made use of this earlier built function. I have made use of this function in the next things, okay. This one. Then I put an if condition and check whether this condition satisfies. If yes, I increase the counter. I started from 0, doesn't matter, you can start from anything. So you really don't have to have a counter. No, you really have to, because why? You are computing a probability. In the chat room, could you show what does it return for being true? Okay. It's again this one. You can give it either way. Same thing. Just to identify that this is a list, you use this notation. It gives the same thing, right? Doesn't matter. Even here, you can give that. This doesn't give it, right? So when you want to access individually the element, then you can either give you this or even this. Doesn't matter. But when you want to further access things, right, it is important to give this notation, otherwise it doesn't work. See, when I give this notation, R doesn't identify that this is the element of a list, this is the element of the vector which is in that list. R doesn't identify. That is the problem. Here I want to access individual elements of the list. That is why I put double square bracket to show, okay, I'm accessing the ith element of the list, and inside that I am accessing the first element. This thing really doesn't work even though this works for the list. I hope you answered your question. Image, yes, image.
Madam, which means the single square bracket is for vectors.
Usually single square bracket is for vectors, double square bracket is for list. But even when you type the single square bracket to access the entire element of a list, it works. But here, can you see in this notation, it outputs double square brackets. Yeah. But when you want to access a particular element within the element, so this is the first element of this list. So if you want to go further in, this thing really doesn't work. It gives you null. That is why I have used double square brackets here. So it's advisable to use double square brackets if you want to access elements of a list, even individually. Although this thing works, it is advisable to go with this notation. It's not wrong to go like this as long as it's working. But to overcome confusions, this way is better. Okay. Okay, thank you for the question. So that's why I have used this way. Why I had the count variable here starting from 0, because that is how I'm going to compute the probability. Out of all the outcomes, the number of events that I have, that I'm interested about. So from 0, I'm counting. If I start from 1, I have to have count minus 1. Okay, so depending on how you define it here, you have to compute the probability. It's not always count over this. If you want to have this, you have to start it from 0. Because from the first element itself, it has to count here. That's why. And you have to return the probability. So let's run this. This is the answer. So if you are asked not to get the probability, but the number of events where the summation is between 11 and 17, if you are asked to get how many outcomes are there where the summation of all the 3 face values are between 11 and 17, simply you have to take the count. Just delete this part. Okay. From this, if you want, what you have to do is multiply it by this. So that is just basic mathematics. So depending on the question, you have to answer. So if you do this, it's the same thing that you have to accommodate here. In the third question, what they ask is to compute the probability that the sum is even. Here you are given a hint that the modulo operator is given by this one. This is the modulus. So if it is divisible by 2, if the summation is divisible by 2, it is even. Otherwise, it's odd. Okay. So here I defined a new function, probability checksum, whether it's even. You can give any name. I just gave it a name where I can identify it easily. And again, I called the first function here and assigned it to an object, this function, just because I want it. I want this, I want to handle all the, I want to access all these, right? So within the same for loop, only this particular condition changes. Summation, same way I'm getting. It's the same code I used, okay? Only this particular condition changes. If summation mod 2 is 0, then increase the counter. At the end, you're computing the probability by count divided by total number of observations that you have. So when you run it, you should be getting 0.5. You can check whether this is doing a proper job by checking the probability of getting an odd summation. How do you do that? Just change this one. Not equal to 0. Then you are getting the odd count. Still it is 0.5. So odds plus evens, those are the only possibilities that you have, right? 0.5 plus 0.5 will give you 1. You know, probability of the sample space is 1. Probability of getting all the outcomes, that is 1. So your answer is, your answer should be correct in that way. You can check like that. Okay. Then the next question is to compare the probability that the mean is exactly 5. Same code you have to use. I'm making use of this one just to get the probability and setting the count. Here the for loop is the same. Here actually earlier I had the sum, now I'm having the average. So I take the sum divided by 3. Or you can simply, I think this works. Let's see. Sometimes when there are too much computations in one line, it doesn't work. Okay. Because of the complexity. We'll see whether it's working. I'm also not sure. We'll see. It should work if it is not too complex. Hmm. Actually, this is the correct answer. Here I'm getting a wrong answer, which means this misbehaves actually. Oh, sorry. Sorry, I gave it in the wrong way. It should work. Still, it's not giving. It really misbehaves. That's why I told you sometimes when it comes to, you know, too much complex things, sometimes these things don't work. I don't know why this gives a wrong answer rather than giving an error. So it's better going it this way. That is the correct answer if you compute. Yeah. So let me just take this out. I should really check why that's happening. Did I give? Right. So how you compute the average is by just taking the sum and dividing it by 3. Actually, the mean function should work in normal case, like say right. So accessing is let's say, this is working. This is not working. Yeah. So when the statements are complex, this function is not really working. Okay, these functions in R, they really misbehave. So it's better going from scratch when you are asked to compute something like this. Okay, so you take the summation when you're accessing elements with the indexes, it really misbehaves rather than giving. When you give this, oh, ah, it gives. The way I gave it was wrong. So this should be, it should work now. Now it should work. You have to give a C there. No, it's okay. So yes, you can give this, but make sure you give this one, because when you are computing the mean of a vector of values, you just can't give comma separated values. You have to give it as a vector. So both these are working. This one and this one both are working. You can use either of them. But sometimes R really misbehaves when the functions are too complex. Sometimes we have to assign this to another variable and then call it in the function. When they are too complex, this is not a complex one as it gives the proper output. When they are too complex, R misbehaves. Most of the time they give out errors. Sometimes they don't give anything. They just compile and wait. Sometimes they give wrong answers. So yeah, so be mindful on that. Anyway, when you're writing answers, you are running the code, checking it. Always it's better to go from scratch, because we don't know what these functions really do inside. We know what mean does, not mean like there are some other complex functions. We don't know the inbuilt situation of those. So it's always better to go from scratch. But in this case, both these are correct. Right. So same way I took the average and then check whether it is equal to 5. That is what the question asks. Exactly 5. If that happens, we increase the counter. That is, you can put any variable here. It starts from 0. Why? Because you have to add it up. Then I compute the probability in the same way and return the probability. So it gives us this answer. Do you have any problem in the way that I have done this? So what I have done here is I have made use of the while loop while this happens, and the for loop. I have made use of the list instead of a matrix, but still y'all can use matrices. But when you are using matrices without inbuilt functions, try to do it from scratch. Because in Devni's and Image answers, Devni's I really can't remember. Image's answer, he had used the function called append. Good to use. But at the exam, if you have not learned that function, then you're in trouble. So always practice to, when you're writing functions, do it from scratch. Then you never go wrong. You can identify the place where you go wrong, right? Because inbuilt functions, we really don't know the mechanism, the exact mechanism. So there could be problems in certain situations. So in matrices, just think of a way of doing it without the append command, the append inbuilt function. Without that, try to do it. Even if you do it with that, it's acceptable, but try to go for different ways. So this is the way that I saw this could be easily done by using matrices as well. Good job. So yeah, so this is my answer. I'll discuss the first one maybe next time, or I'll put the answers I put pending there because I have to check. Is that Madhushi who got some answer like 133? Is that Madhushi? The
Yes,
person
ma'am.
who I, yeah. Can you please email your code to me so that I can check that out? And I'll get, have you emailed?
Ma'am, it's me.
All right. Okay. So I just email me the code. I'll go through that and get back to you all with an answer. Okay, so that's it for today. Thank you very much for trying this out, and you can further try this. I'll upload this R script today, but without, straightforwardly going to this one, try to come up with different answers. The ones who have not gone for answers, you'll have to put some more effort on this. I know this couldn't be done that easily. This is an exam question. Last year paper, I think there were like 3 or 4 questions, so this is just one of them. Don't panic, because at the exam sometimes these things cannot be completed, I know. But when you keep on practicing, these are not going to be that hard. So don't panic, this is not going to be hard. Just try to understand the concepts. Always try to go for things from scratch by using your own logic. Then you don't have to learn a lot of things. For example, the command append, if you have not learned that, still you should be able to do this. So so that is the advantage of practicing these things from scratch. So further practice this. We'll meet you next time with a new lesson. I'll discuss the part A also. Thank you very much for trying this out, putting the effort, and I hope you all are happy with this. Anyway, you have to get used to these things. Right, if you don't have any questions, you all can leave the session. Thank you very much. Stay safe.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you.